call these critical points, okay? No, where is it? Oh, yay, thank you. Oh, it gets us the best hair. Oh. All right. Debatable. All right. So just to kind of make my point about what we're doing is so far we've been able to find what we call these critical points. And the reason why critical points are important is they show us what we call hidden behavior of the graph. And so that little graph I've just drawn up there is just a short example for us. That graph has local min, a local max, an absolute min, an absolute max. See if you can identify which spots on this graph are a local min, local max, an absolute min, and absolute max. Talk with your friends. Go. What do you got? Go. And stop. Let's start by the absolute max. You tell me when I get to the absolute max. Yeah, that's the absolute max. Okay? You tell me when I get to the absolute min. Yeah, that's the absolute min. Okay? It's the lowest spot on the graph. Okay? You tell me when I get to a local min. Yeah, this is also a local min. You tell me when I get to a local max. Yeah, local max. So this endpoint is neither a local min or local max or absolute min or absolute max, right? So where you get in trouble in mathematics is where you start to think about what is always true all the time and try to isolate situations to one case. The fact is that this point happens to be the absolute min and the local min. So if you, true or false, an absolute min can happen at an endpoint. Yeah. So when you are trying to find the absolute min and max, the first thing you need to do is find the critical points. Now we found the critical points. We did that the past couple days. Yeah.
Can you have a local min?
Not at an endpoint. Okay?
Can't have a local.
Can't be a local at an endpoint. Number two, you then want to also check the endpoints. And finally, number three, you want to compare. I'll show you what check the endpoints means. Okay? So I'll be referencing back to that graph here in a second. We try a couple examples, find the absolute max and min of the functions over the given intervals. So we're not being asked to find a local min or local max right now. We're asked to find the absolute min and absolute max. So the first thing I do is I find the critical points. Critical points I determine by doing f prime of x. What is f prime of x? 2x minus 4. And I set that equal to 0. That happens at x equals what? X equals 2 is a critical point. So I did the first step. I found the critical points. X equals 2. I'm going to check the endpoints as well. What are the endpoints? 0 and 6, right? So I check the endpoints and I check this spot, which is a critical point. Very similar to when we were doing that whole distance and velocity thing, remember? We had the starting point, we had the ending point. Then we just figure out where the function is. So let's determine f at those spots. If you plug 0 into this function, what do you get? You get 3. If you plug 2 in, you get 2 squared is 4. Minus 8 is negative 4. Plus 3 is negative 1. Now I'll plug in 6. 6 squared is 36 minus 24. 12 plus 3, 15. So what is the absolute maximum value? It is 15. Like if we were to look at this graph, it might look something like that, right? Might look something like that. I'm just drawing a quick sketch. But the idea is from 0 to 6, you have a maximum value here of 15. So absolute max, and we refer to an absolute max, we're referring to the y value. Absolute value, or absolute max of 15. Absolute min of what? Negative 1. Okay? No, it's not bad at all. The only thing different than finding, or finding the critical points, now we're just checking the endpoints to see where it's at. That's all we're doing. That's all that's different. Well, in that case, 0 to 6. In this case, it's negative 6 to 3. Okay, question?
So the stuff that we were doing like yesterday, that's the critical point?
Yep, that's a critical point. We found that spot right there. Now, later on, we'll identify that this is a local min. Technically, we need to do a little bit of work to show that that for sure is a local min. Okay? All right, next one. We'll take the derivative and set it equal to 0. What's the derivative?
6x squared, 6x.
Does that factor?
Yes.
What if it didn't factor? What if it didn't factor? What could I use? Quadratic formula. And you have that right into your calculator, don't you? But we know how this factors. We don't need that right now. We got 0 equals 6 times x squared plus x minus 6. Does that factor? To what? X plus 3 and an x minus 2. So where are my critical points? So my endpoints are negative 6 and positive 3. And then my critical points are at negative 3 and 2. Now, if I'm allowed to use my calculator, then I would just plug it in and evaluate all those on the table. Do you remember how to do that on your calculator? I'm going to quick grab my calculator and go through that. Could somebody read it off to me, please? We have, is it 2x cubed? Okay, 2x to the third. Then what? 3x squared. 36x plus 4. Okay? So I can go to my table, and hopefully everybody has their table set to ask as opposed to automatically generate. I plug in the values negative 6. Then what? Negative 3. 2 and 3. So those are my values right there. Made pretty quick order out of it. So I can tell that in this interval, I've got negative 104, got 85, negative 40, and negative 23. So I've got an absolute max of an absolute min of, yeah. That's it.
That's it?
Yeah. So the whole critical points thing we did yesterday, we're going to build off that in the next lesson, and that's going to be used a lot throughout AP Calculus. This whole checking the endpoints thing, that comes up as usually a last question on the free response. Usually comes up a couple times. Like what for sure is the absolute max or min. If people just forget to check the endpoints. Flip it over. We're not going to do example 5. And for these two, we're going to use our calculator. Okay, so we need to be able to use our calculator to determine some of these things. You all got it? So as opposed to taking the derivative, all I'm going to do is just plug this in. What? Yep. Sir. Okay. So let's glance at this. I'm going to graph it. I'm just going to zoom 6 and see what I do. I want you guys to help me here, okay? Now, can somebody tell me what would you first do to see that graph better? How would you change the window? What would you change Y min and Y max to? Okay, -3 and +3. Good. I like the way you're thinking. All right. So I'm not actually going to find the derivative. I'm going to look at this graphically. I have my X value and I have my F. Okay, looks like I have -9 and +9 are my endpoints. So you tell me between -9 and +9, how many critical points do I have? Pause. A critical point is where the derivative is equal to 0 or the derivative does not exist. You tell me when I get to a spot where the derivative is 0 or it does not exist. Yeah, that's for an X value of what? Folks, let's try again. What's the X value here? 0. The Y value is -1. Very good. So I've got my endpoints. I can see exactly where that spot is, okay? And I'm going to calculate, or I'm sorry, I'm going to go to my table, and I type in -9, I type in 0, and I type in 9. So I get 0.8, -1, and 0.8. So what's the absolute max? And what's the absolute min? Yeah, I can do that using your calculator.
Yeah, mine looks like no. No way.
So your X min and your X max is just a -1 and a +1. Press zoom 6 and see what you get.
When I did mine, it was so I got
I don't know. I'll have to come back and fix that. Don't know the deal. Shh. And we do our last one. You guys can have time to work. I'm not going to use this one with my calculator. I'm going to do this one by hand because it comes up in your previous assignment a little bit. We want to make sure we get this. I need to find the derivative of this. I know that I have a t value and I have an f value. Now my t value I'm going to check from 0 to 8, but I have to check any critical points that exist between there. Okay? So how do I take that derivative? Product rule, right? So the product rule, because I have that times that, right? So I have f prime of t. What's the derivative of t to the 1/3? Very good. So the derivative, as Easton said, is 1/3 times t to the -2/3. I could also write that as 1/3t to the 2/3. Everybody okay with that? Times what? 8 minus t. Plus or minus? Plus. What's the derivative of 8 minus t? So we'll just make a minus, won't it? Minus, and I'm going to write that as t to the 1/3. I'll write it as over 1 since it seems we have a fraction. I want to show you a way in which we can deal with this type of equation, because although it's just algebra, we've learned that algebra can be challenging. That's an 8 minus t in the top. And the bottom, I have a 3t to the 2/3 minus t to the 1/3 over 1. And I set that equal to 0 to find the critical point. So if you have a fraction like this, and I started to introduce these problems because I've seen these multiple times in the AP exam, I need to create one fraction. I look where the top is equal to 0 and where the bottom is equal to 0. What do I have to do in order to create one fraction? Common denominator, so I'm going to multiply the top and bottom by 3t to the 2/3. Again, this is very similar to a problem we have on your previous assignment. And I get 8 minus t. And then what is 3t to the 2/3 times t to the 1/3? Just 3t, right? So minus 3t over 3t to the 2/3. What do I now have in the top? Over 3t to the 2/3. Where is the top equal to 0? At 2. Where is the bottom equal to 0? At 0. And we already have that. We'll accept that, but it was rather weak, wasn't it? Okay. All right. So what I want you to notice here is that 0 was already there because it was an endpoint, wasn't it? So now I could just go to my calculator. Y equals, I'll type in the cube root. The cube root of x times 8 minus x. And as I go into my table, I type in 0, I type in 2, and I type in 8. So I have 0, I have 7.555, and I have 0. Oh yes, thank you. So my absolute max is 7.559. The AP exam will ask you to go to 3 decimal places, and then the absolute min is 0 in that situation. And we can be confident of that. If you want to check your answer, just glance at the graph, and the graph should show that you have a max of 7.55 and a min of 0. Okay? The 4 problems on the front, you do by hand. The 2 problems on the back, you use your calculator. Got it? What? Right. Yeah. Amen there, Hattie. Okay, I'm going to answer a few questions, okay? Trey will be with you in a second. Okay.